Have you ever heard the idea of Tartarian palace stations, 1880, 1910, why their halls were built like giant resonators? And thought, that can't be real? Because these old stations don't look like normal train buildings. They look like palaces, giant domes, endless stone halls, arches that feel too perfect. And when you stand inside, something is off. The room doesn't just echo. It swallows sound, then throws it back like a wave, like the whole building is a tuned instrument. Now, here's the part nobody explains. If it was only about passengers, why build halls this huge, with shapes that match acoustic chambers? Why do some stations feel like they were designed to carry vibration? Through stone, through air, through the floor, like a hidden machine you can't see. And then you notice the strangest pattern, the same era, the same palace station style, repeating across different cities. Like it came from one blueprint, one idea, one purpose. So, what were these stations really for? Just trains and crowds? Or did these palaces once do something else? Something they stopped talking about? If these halls were built like giant resonators, what were they supposed to amplify? You walk into the main hall of a grand station at night. The crowd has gone. The announcements have stopped. The last train pulled away an hour earlier, and now it's just you, the marble, and the silence. You take a step. The sound doesn't behave the way it should. Your footstep doesn't just echo, it lingers. It hangs in the air like a note held too long. You stop moving, but the sound keeps going, rolling through the arches, sliding down the columns, circling back from somewhere you can't see. You tap the wall. A faint hum answers. Not an echo, a response. Like the building is tuned. This is the moment restorers and maintenance workers describe when they're alone in these old palace stations. The moment when a place stops feeling like simple architecture and starts feeling like an instrument built on purpose. One restorer in a European station, built in 1889, was repairing a decorative panel near the base of a support column. He tapped it lightly with a tool, just to check for hollow space behind the surface. The panel rang out. A single, steady note. Clean. Held far too long. He tapped again. Same pitch, same length. He moved to the next column. Different tone, but just as clear, just as stubborn, refusing to fade when it should. He walked the length of the hall, tapping columns, arches, hidden panels. Each one answered with its own distinct pitch. Each one held the sound longer than a normal building has any right to. Later, he brought in an audio engineer. They ran tests. The columns weren't just hollow, they were tuned. The cavities inside matched specific frequencies. When struck, or even when nearby sound built up, they didn't simply reflect noise. They strengthened it at precise points. Like the building had favorite notes. The engineer's report noted something else. The hall itself, its dome, its floor plan, its curved ceiling, could lock into one dominant frequency when sound reached a certain threshold. Like blowing across the mouth of a bottle. Except the bottle is a cathedral-sized room of stone and steel. The whole space becomes a resonance chamber. His conclusion was blunt. This wasn't an accident. But why would a train station need to behave like a musical instrument? The official story is simple. These stations were built during an empire boom, 1880 to 1910, a time of wealth, pride, and progress. Cities wanted monuments, palaces of steel and stone, proof that the modern age had arrived. So they built grand halls, vaulted ceilings, iron ribs, glass roofs that poured light down like columns. Spaces designed to make every passenger feel small and impressed. That's the story. Yet when you look closely, the design choices don't quite fit. Double walls where single walls would do. Sealed cavities with no clear job. Repeating dome shapes that appear in stations across different countries. Different architects, different budgets. Yet somehow the same proportions keep returning. Hollow columns that could have been solid. Air ducts that lead nowhere. Metal ribs placed at intervals that make more sense for where sound peaks than for where weight would demand support. One architect's notes describe resonant cavities for air circulation. Another mentions harmonic stabilization of interior acoustics. A third doesn't explain anything at all. He only lists measurements, ceiling height, dome radius, column spacing, ratios that line up with known resonance formulas. None of them ever say why a train station needs harmonic stabilization. The floor plans reveal more. In one station, a curator found blueprints for a section labeled air chamber system. The chambers ran beneath the platforms, connecting to vertical shafts that rose into the columns. The drawings show exact angles, calculated volumes, and notes about frequency response under load. The official records called them ventilation ducts. But the measurements didn't match standard ventilation engineering. The chambers were too large. The angles were too specific. The placement was too deliberate to be an afterthought. When engineers tested the surviving sections, they found something unexpected. The chambers didn't just move air. They amplified low-frequency sound. Vibrations from trains, from crowds, from the building itself, fed into these hidden spaces and came out louder, clearer, more focused. One engineer described it as a subwoofer built into the foundation. Another called it a tuning fork the size of a city block. And then you find the second station. Different city, different architect, built 7 years later. Same hidden chambers, same hollow columns, same dome. Proportions. The pattern repeats. You start looking at archival photographs, not because you want to, because once you spot the same strange choices in one station, you can't stop asking if they show up in others. And that's when you find an image that shouldn't exist the way it does. The photograph is from 1892, a grand opening ceremony. The main hall of a palace station in Central Europe, freshly finished, gleaming with new marble and polished brass. Dignitaries stand in stiff rows. Chandeliers hang from the vaulted ceiling. Light cuts through the glass roof in clean diagonal stripes. Everything looks exactly how you'd expect, except for one detail near the upper gallery. Just above the chandelier mounting point, there's a circular structure, a ring. Metallic, maybe about 3 meters across. It sits partly behind decorative stonework, but you can see enough to know it isn't part of the chandelier system. The ring looks anchored into the dome itself. Metal brackets, tight angles, fixed points that feel planned, not improvised. It's too precise, too built in. So, you do what any obsessed researcher does next. You look for more photos of the same station, later prints, official postcards, tourist brochures from the 1900s. And the ring is gone, not taken down, not missing, blurred, painted over, retouched until it never existed. In one version, that whole area is darkened, shadow where detail should be. In another, the stone pattern has been stretched in the print, covering the exact spot where the ring was. In a third, the work is sloppy enough that you can see faint brush marks, even through the age and grain of the photo. Someone didn't just lose a detail, someone worked to erase it. You bring it to a curator. She studies the original print under magnification. The ring is there, faint, but real. Then she pulls later prints made from the same source image. The ring has been retouched out in every single one. Why would they do that, you ask? She gives the standard answer. Retouching was common. They cleaned up flaws, removed clutter, made pictures prettier for the public. But this isn't clutter, you say. It's a structure. It's anchored into the dome. She looks again, longer this time. The brackets, the alignment. The way the ring follows the curve of the ceiling, like it was designed to belong there. I don't know, she admits. Maybe it was removed during renovations, and they didn't want people seeing an unfinished ceiling. But the renovation records say nothing about removing a ring. No work order, no salvage list, no note about extra metal, no photo of workers taking it down. The ring doesn't get removed, it simply stops appearing in history after 1896. Then you find a second example in a different city. Same era, same kind of palace station. This time it's a calmer photo, less ceremony, fewer people, more details visible. Along the upper ledge of the hall, you can see a line of metal fixtures, not lights, not supports. Curved panels, evenly spaced, set at regular intervals around the hall like they were placed on purpose. In photos from 5 years later, those panels are gone. The stone trim is the same, the hall is the same, but the fixtures have either been removed or edited out. You put the prints side by side, and there it is again. The soft edge where a hard edge should be. The lighting that doesn't match the rest of the picture. The faint ghost of a bracket still visible in one corner, like the retoucher missed a spot. The official archive catalog describes both images with one bland line. Interior view, main gallery, circa 1894. No mention of changes, no warning, no explanation. One researcher finds a third case in a station in Eastern Europe. An early photo, taken during construction, shows a circular platform being installed in the center of the main dome. The platform is maybe 2 meters wide, hanging by cables from the iron ribs overhead. Workers stand around it with tools in hand, staring up at something just outside the frame. Later photos show the finished hall, no platform, no cables, no anchor points where the platform would have connected. But the construction ledgers list materials for an interior platform assembly. They record the delivery of the cable, metal framing, and mounting hardware. They even note the installation date. They never record its removal. When you push archivists on these contradictions, you keep hearing the same line: retouching errors, standard practice. But these aren't random smudges. These aren't scaffolds cleaned up for a postcard. These are built features: metal rings, mounted panels, suspended platforms, installed during construction, then scrubbed from the visual record within a few years. And the more palace stations you check from the same period, the more the pattern returns. Photos with details blurred out, prints with visible paintwork, features that appear early and vanish later. Always the same type of feature, always metal, always placed where sound would gather and bounce, near domes, along galleries, above the hidden chambers you saw in the plans. The stations were built with something extra, something that doesn't fit the clean story of train terminal or passenger monument. And then quietly, carefully, that extra was edited out of memory. The standard explanation is simple enough. These were empire stations, built at the peak of industrial power, cities competing for prestige. Architects handed huge budgets and one clear instruction: make it grand. So they did. Marble floors, vaulted ceilings, iron lacework that looked like frozen music, glass roofs that turned sunlight into cathedral light, halls so big they made travelers feel small, like they were standing inside progress itself. That's what the history books say. And for decades that story was enough. But then engineers started looking at the construction itself, not the ornaments, not the pretty choices, the decisions that had nothing to do with beauty, and everything to do with how the building works. Double walls where single walls would have done the job. Not for insulation, these stations weren't heated evenly. Not for quiet. The halls don't try to soften sound. They push it around. They carry it. Just double walls, with hollow spaces between them, spaces that connect to vertical shafts running up through the columns, like hidden lungs inside the stone. Sealed chambers beneath platforms, too large for drainage, too carefully shaped to be simple storage, almost always placed under the center of the main hall, directly below the dome. And then there are the domes, not just similar. The proportions repeat so closely it gets uncomfortable. A station in Vienna has a dome with a 24-meter radius and a 16-meter height. A station in Budapest, built 6 years later by a different architect, has a dome with the exact same measurements. A third station, different country, different railway company, matches both. The ratios repeat 3-2, again and again. One structural engineer described it like this: imagine you're designing a building to move crowds fast. You want wide passages, clear sight lines, obvious exits. You don't want echoes confusing announcements. You don't want sound bouncing in weird ways. But these stations are built to do the opposite. The domes focus sound toward the center. The arches create reflection points that boost certain tones. The main halls, round or oval, match the same layouts you'd expect in a place built for sound. It's like someone designed a concert hall and then added train platforms as an afterthought. Here's a simple example. When you blow across the mouth of a bottle, it makes a tone. The pitch depends on how much air is inside and the shape of the opening. The bottle becomes a resonator, something tuned to make one note louder. Big rooms can do the same thing. If a hall has the right proportions, height to width, curve of the ceiling, placement of hard surfaces, it can lock into one main note. Any sound near that note gets boosted. Other sounds get scattered or swallowed. Concert halls use this on purpose. Opera houses are built around it. The goal is clear sound, one voice carrying across the room without turning into mush. But why would a train station need that? Trains are loud and messy. Crowds shuffle, cough, laugh, shout. Announcements need to cut through noise, not make the building sing along. In a busy terminal, you'd expect designers to aim for a calmer space, flatter sound, fewer harsh echoes, less confusion. Yet these palace stations do the reverse. They don't try to go quiet. They're shaped to ring. The pattern becomes hard to ignore when you map it. A researcher in Germany plotted major palace stations built between 1880 and 1910, 53 stations across Europe, different railway companies, different architects, different governments. But the same features keep coming back with strange consistency. Domed main halls, 41 stations, hollow support columns, 38 stations, sealed basement chambers, 29 documented, likely more that never made it into records. Iron rib ceilings in specific geometric patterns, 34 stations. Oval or round main halls, 36 stations. And the measurements, the magic ratios of height to radius, dome, curve to hall length, cluster around the same values again and again. Not always identical, but close. Like variations on a theme, like different instruments built to play the same note. One architect's private letters, found in a municipal archive, give a glimpse behind the official story. He describes a meeting in 1887 with railway officials and technical consultants, whose names are never written down. They gave him design parameters, minimum ceiling heights, required dome proportions, and exact instructions for hollow column construction. He writes, "The requirements seem excessive for passenger comfort alone. When I suggested changes to reduce cost, I was told the specifications were non-negotiable. The measurements must be exact." Another entry, dated 3 months later. "Construction proceeds as directed. The hall resonates beautifully, though I confess I do not fully understand the purpose of such acoustic precision in a railway terminal." A final note, written after the station's completion: "They have installed equipment in the basement chambers. I was not consulted. I was told it relates to signaling systems, though the installation does not resemble any telegraph or electrical apparatus I have seen." 2 years later, a second station opened in a nearby city. Same design parameters, same dome proportions, same hollow columns, different architect, same mystery. Once you know what to look for, the clues start stacking up, not in the spotlight, not in glossy museum captions or proud city histories. You find them in the margins, in papers nobody thought would matter, in small notes workers wrote for themselves, never imagining someone would read them a century later. A blueprint surfaces in a railway archive in Prague. It's labeled "Ventilation System, Lower Level," and dated 1891. A normal engineering drawing at first glance. Clean lines, careful measurements. Nothing that screams mystery, except the air chambers don't match how ventilation is usually built. They're too big, too carefully shaped. The cross-sections show curved walls, domed ceilings, and metal linings. The chambers connect to vertical shafts that rise through the building, ending at specific points in the main hall. Always near columns, always spaced at measured intervals. A modern ventilation engineer studies the drawing and gives a blunt assessment. This isn't designed to move air well. The curves would make messy airflow. The metal linings would carry temperature instead of blocking it. If anything, this would make ventilation worse. So, what was it for? The blueprint has margin notes, not airflow notes, sound notes, frequency calculations, resonance formulas, notes about harmonic load distribution, and standing wave formation. That language belongs to acoustics, not ordinary railway construction. Then a second document shows up in a different archive, a materials ledger from a station built in 1889. Normal bookkeeping, deliveries, weights, costs, supplier names. The kind of record that usually tells you nothing except who paid for stone and steel. But buried in the entries are items that don't fit the story of a public train station. Copper tubing, 400 meters, hollow core, 3 centimeters diameter. Iron plates, resonant grade, 200 units, various thicknesses. Mounting brackets, adjustable tension, 86 sets. Crystal elements, piezoelectric specification, 12 units. The copper tubing doesn't match any plumbing layout. The iron plates don't appear in structural plans. The adjustable brackets don't show up in any documented installation. And those crystals, in 1889. The effect was known by then, discovered in 1880, but only a small number of researchers were even talking about it, and practical uses were still rare. These are crystals that can create an electrical effect when pressed or stressed, yet someone ordered 12 units. Someone placed them somewhere. The ledger even lists the installation date, November 14th, 1889. It records the crew, special technical crew, external contract. It notes the location, sub-level chambers, restricted access. And then it says nothing else. Then you find the worker's note. It's tucked into a maintenance log from a station in Austria. Not an official report, just a handwritten entry in a daily record book. The kind of thing a night supervisor leaves for the morning shift. The date is March 3rd, 1893. Tested the equipment after midnight as instructed. Kept distance as warned. Low hum persisted for 40 minutes. Felt pressure in chest. Asked again about purpose. Told it relates to signal synchronization. Does not resemble any signal equipment I know. And that's where it ends, because the next page has been torn out. Now the story starts to rhyme across cities and years. Equipment arrives. Installation happens late. After closing, after midnight, during quiet hours. The work is done by external contractors and technical specialists whose names don't appear in normal employee lists. The installations happen underground, in basements, sealed, chambers and spaces that exist on blueprints but never get explained in the official build story. And then the records break. Ledgers end midstream. Maintenance books have missing pages. Blueprint sets jump numbers. Pages marked 1, 2, 3, 5, 6, 8, with the missing pages always covering the same areas. Basement layouts, equipment specs, installation steps. One archivist describes finding a complete set of station plans with one whole section physically removed. Not misplaced, removed. The binding shows clean cuts. Someone took those pages out carefully and left everything else untouched. The missing section was titled Auxiliary Systems. This isn't one odd station anymore. It's not one architect's weird taste or one railway company doing a special project. It's systematic, coordinated, repeated across borders and across years with too much consistency to shrug off. These palace stations weren't built only to impress travelers. They were built to do something. And whatever that something was, someone decided it shouldn't be remembered. You begin plotting locations. Every palace station built between 1880 and 1910. Every confirmed case of hollow columns, sealed chambers, or edited photographs. Every time the paperwork goes missing. Every time special equipment appears with no explanation. Red pins go into the map. One by one, Vienna, 1888, Budapest, 1894, Prague, 1891, Berlin, 1902, Warsaw, 1899. The pins cluster across Central and Eastern Europe, then creep westward, Paris, Milan, Barcelona. Each station built in the same tight window of time, each one following the same design logic, even when the architects have no clear link to each other on paper. And then you start seeing the signatures repeat, domed main halls with specific proportions. Not sort of similar, not close enough, mathematically precise. A 3-to-2 ratio of radius to height shows up again and again, across 6 countries. Like someone handed out a formula, not a mood board. Long entrance galleries with arch ceilings. Always the same length compared to the main hall. Always the same spacing between arches. One researcher measured 7 different stations and found the arch intervals varied by less than 30 centimeters. Across buildings separated by thousands of kilometers. Iron ribs holding up glass roofs. But the ribs don't just hold glass. They form repeating geometric patterns, radiating from central points, crossing at careful angles. Patterns that match modern sound-scattering layouts, the kind used to spread sound evenly instead of letting it pile up in one spot. Tiled vaults in certain color arrangements. At first, it looks like pure decoration, mosaics, local style, national pride. But when the layouts are studied closely, the tile patterns line up with where sound pressure would peak and dip. Harder tiles sit where sound would slam hardest. Softer materials show up where it weakens. The decoration starts looking less like fashion and more like function. And then there are the basements. Every single palace station has extensive underground spaces, far more room than you'd need for basic machines or storage, rooms that mirror the shapes above them, vaulted ceilings below ground, smooth, polished stone walls, even in areas passengers were never meant to see. It feels like somebody built a second station under the first one. One architect's journal, found in a family estate and never published, adds a human voice to the pattern. He writes about traveling to see recently completed stations. He visits 4 cities in 1896, studying their palace terminals like a detective. He sketches floor plans, measures dome curves, records where each support column sits. Then he writes something that makes your skin tighten. The halls speak to each other. I do not mean metaphorically. Stand in the center of Vienna's main hall and clap once. The sound returns, in a specific pattern. Do the same in Budapest. Different hall, different echo, yet the pattern is related, as if they were designed to recognize each other. He keeps going. I tested a theory. I brought a tuning fork calibrated to Vienna's dominant frequency. I struck it in Budapest's hall. The space responded. A faint resonance, barely noticeable, but real. The halls are tuned to compatible frequencies. A later entry, dated 3 months afterward, turns colder. I have been discouraged from publishing my findings. The Railway Commission suggests it would invite unnecessary speculation. I am told the acoustic properties are incidental, a side effect of grand design. I am told to focus on aesthetics, not function. Then he leaves the question hanging like a threat. But if these properties are incidental, why are they so consistent? The map reveals something else too. The stations aren't scattered randomly. Yes, they follow rail lines, but not all rail lines. Certain routes keep showing up. Certain links repeat. When you connect the dots, you don't just get a web, you get shapes, triangles, sets of 3 stations placed like near-perfect mirrors of each other, lines, stations spaced like beads on a string, with distances that keep landing in the same range. One researcher tried overlays. First, telegraph maps from the same era, no match. Telegraph systems branch like roots, following business needs and population. Next, geological layers. Still no clean answer. Then, elevation and terrain. Again, nothing that explains the pattern. Finally, he overlays underground water maps, deep aquifers, underground rivers, and rock formations known to carry vibration. And that's when the alignment starts to show. Not perfect, not magical, but strong enough to make you stop and stare. Stations built over deep aquifers. Stations placed where bedrock could act like a natural soundbox. Stations sitting on points where the ground itself might help carry low vibration farther than air ever could. The map doesn't shout the conclusion. It whispers it. These halls weren't designed only to resonate one by one. They might have been designed to resonate together. A network, not of trains and passengers, but of sound, of vibration, of frequency, moving through stone, through earth, through the hidden architecture under the city. And if that's even partly true, these palace stations weren't just terminals. They were nodes. The idea sounds impossible at first. Buildings designed to send vibration across distance. Halls tuned to talk through the ground. It sounds like fiction, not history. But then you look at the engineering, and the engineering starts to click. Start with one basic idea. Resonance. Every object has a natural frequency, one favorite beat where it vibrates the easiest. Push a child on a swing at the right rhythm, and small pushes stack up into big motion. Push at the wrong rhythm, and you waste energy fighting the swing. The same thing happens with real structures. Buildings, bridges, even whole hillsides have resonant frequencies. Engineers spend their lives measuring them because the wrong vibration can crack walls, twist metal, or, rarely, bring something down. But resonance isn't only a danger, it can also be a tool. Think about a tuning fork. It works because it's shaped to vibrate at one clean note. Strike it, and it rings. Press it against a table, and the table starts speaking too. The vibration moves into the wood and gets louder. Now scale that up. Make the tuning fork the size of a building. These palace stations have the exact features you'd want for that kind of system. Hollow columns act like vertical resonators. When vibration enters near the base, it can travel upward inside the shaft. Certain tones get stronger, and others fade out. the column becomes a filter, letting some notes through while smothering the rest. Domed ceilings don't just look grand, they focus and reflect sound. Noise rising into a dome can gather toward a sweet spot, then spread out again in a controlled way. Ancient amphitheaters use this trick to carry voices. These stations use similar geometry, just on a much larger scale. Curved walls and long arches can form sound corridors. Instead of sound scattering everywhere, it tends to slide along the curves and return to predictable places. Like water following the shape of a channel, vibration follows the shape of the room. Metal ribs embedded in walls and ceilings add another layer. Stone holds its shape well, but metal carries vibration more easily. Put them together, and you get a structure that can both contain vibration and move it along. And those sealed basement chambers, they are almost perfect echo boxes. They're cut off from street noise, shaped with care, and placed directly beneath the main halls, right where the weight and vibration from above would naturally press into the ground. One acoustic engineer ran a simulation. He entered the measurements from an 1889 palace station: dome size, column spacing, ceiling height, basement chamber volume. Then he calculated the resonant frequencies of each part. The result was the first real shock. The pieces weren't tuned to one single note. They were tuned to related notes, harmonics, like steps that fit together on the same ladder. The basement chamber sat at a deep bass tone. The columns strengthened a higher related tone. The dome reacted to another, higher again. Together, the building formed a chord, multiple linked frequencies stacking up without crashing into each other. That's how instruments get powerful without turning into noise. Organ pipes do it. String instruments do it. The parts are built to agree with each other. The engineer's conclusion was simple and scary. This building is designed like a musical instrument, not as a metaphor, literally. Each architectural element behaves like a working part of a resonant system. But instruments don't play themselves. You can build a perfect violin and it stays silent until someone pulls the bow. So, what played these stations? What fed them energy? The obvious answer is trains. Every arriving locomotive sends vibration through the platforms, into the foundation, and up through the structure. Huge weight, steel wheels, braking, acceleration, repeating mechanical pulses, strong enough to shake a city block. But there's a problem. Trains are messy, schedules change, loads change, speeds change, delays happen. You can't tune a delicate system to something that random, unless the trains weren't random. Timetables from the 1890s show something curious. During certain hours, often late evening when passenger traffic dropped, trains arrived at very exact intervals, not about, exact. One station's logs show evening trains arriving exactly 12 minutes apart for 3 hours. Another shows 18-minute intervals. Maintenance records wave it away as signal testing or track inspection. But 12 minutes and 18 minutes share a relationship. 12 minutes is 720 seconds. 18 minutes is 1,080 seconds. The ratio between them is 2 to 3. The same kind of clean musical relationship you see inside the building's design. So the stations weren't just resonators. They were resonators built to be activated on a schedule. Instruments waiting for the moment when architecture, timing, and mechanical force all lined up. And when they did, the halls wouldn't just echo, they would sing. To understand why anyone would build resonating stations, you have to understand what cities needed in the 1880s. Power, not political power, electrical power, and cities were hungry for it. The modern city was being born in this era, but it was born with dim eyes. Gaslight lit streets and buildings, but it was weak and yellow. Factories ran on steam, but it was noisy, wasteful, and hard to control. Telegraph lines connected cities, but the signals were thin, jumpy, and easy to disturb. Then Edison's Pearl Street Station opened in 1882. Electric light, bright, steady, shocking. Cities rushed to copy it. Power plants went up. Cables went into walls and streets. Within a decade, big urban centers had electrical grids, at least on paper. In real life, those early systems were a mess. Early power couldn't travel far without weakening. Direct current, power flowing one way, lost strength over distance. A generating station could light a few blocks, but areas about 1 mile away stayed dim or went dark. To cover a whole city, you needed more plants, backup lines, and crews constantly fixing problems. And problems kept coming. Cables failed. Insulation softened and burned. Connections sparked. Underground conduits filled with water. In winter, ice pulled down overhead lines. In summer, heat pushed systems past their limits and parts overheated. The technology was new, the infrastructure was fragile, and demand kept climbing. Railway stations had it even worse. They needed power for lighting, platforms, ticket halls, waiting rooms. They needed power for signals, switches, track control, safe timing to prevent collisions. They needed power for clocks, so schedules matched across multiple platforms and across whole cities. And they needed all of it to work every time. A dead signal could cause a crash. A dark platform could injure passengers. A clock that drifted could throw a busy network into chaos. Station records from the 1880s and 1890s are packed with the same kinds of complaints. Lights failed during evening service, platform evacuated. Signal malfunction caused 12-minute delay, 3 trains affected. Clock system lost synchronization, manual reset required. It wasn't rare, it was normal, and it was expensive. So engineers looked for alternatives. One approach was pneumatic power, compressed air. Paris built a wide pneumatic network in the 1880s, tubes under streets sending pulses of air pressure that could trigger machines. It worked, but only up to a point. Air pressure fades over distance. The system needed constant care, and no matter how clever it was, it couldn't light a hall the way electricity could. Another approach was mechanical linkages, physical cables and rods. Pull a lever in a control room, and a long cable moves a switch far away. These systems worked too, but they were slow, they snapped, and winter could turn them dangerous when ice locked parts in place. What cities really wanted was a way to move energy without fragile cables at all, or at least a way that didn't depend on lines that could be cut, flooded, burned, or torn down by storms. A method that could send power through something tougher, through the ground, through stone, through a building's own bones. Nikola Tesla proposed exactly that in the 1890s, wireless power through resonance. The idea was simple in words and wild in practice. Send energy using tuned frequencies, like matching notes, so one system could push another at the right rhythm. He believed energy could be transferred through the Earth itself if everything was tuned correctly. He built a prototype site, Wardenclyffe Tower. Construction began in 1901. It was never finished, funding collapsed, the project became a famous what if, and the public story says the idea was impractical. But here's the uncomfortable overlap. Tesla filed early patents related to wireless power transmission in 1891. The same year, palace stations begin showing signs of unexplained equipment being installed in their basements. Official records describe this equipment with careful empty labels. Signal synchronization apparatus, auxiliary, timing mechanisms, experimental communication devices. But when specifications exist, they don't read like normal telegraph work. They point to resonant cavities, frequency hardware, and materials chosen for sound behavior, not just strength or cost. One maintenance log from 1894 records testing the resonance equipment during low traffic hours to avoid interference with passenger service. Another describes shutting down the harmonic system for repairs after a failure caused sustained vibration in the main hall that alarmed late-night travelers. A third mentions recalibrating the frequency transmission apparatus to match neighboring station specifications. These aren't the notes of a telegraph operator writing about wires and clicks. They read like the notes of someone tuning an instrument, only the instrument is a building. The power problem was real, the need was urgent. And these palace stations, with resonant architecture, timed arrivals, and basement systems nobody wants to describe clearly, appear right in the same window when cities were searching for a breakthrough. So, the question isn't just whether these stations could have been used for wireless power experiments. The question is, what happened the moment they turned the system on? The experiments didn't happen in quiet laboratories. They happened inside working stations, with passengers walking through, with workers posted in the halls, with real people standing inside the resonator, often without realizing what they were part of. And some of them noticed. A young engineer's diary, dated 1893. He's 26 years old, fresh out of technical school, proud to be assigned to a new palace station, a monument to progress, a symbol of the modern age. His early entries are bright. He describes construction with careful detail, the precision of the dome, the beauty of the iron ribs, the way afternoon light pours through the glass roof and lands on the marble like water. Then, the entries shift. June 14th, the Railway Commission has requested modifications to the basement design. The new plans include chambers that serve no clear ventilatory purpose. When I inquired, I was told they relate to acoustic management. I have not been trained in acoustics. July 3rd, installation of equipment continues below. Access is restricted. I asked to observe as the work intersects with foundation elements under my supervision. My request was denied. I am assured the structural integrity will not be compromised. August 18th, the hall resonates differently now. Before, sound echoed as expected. Now, certain tones linger. Others vanish completely. I stood at the center and spoke. My voice returned to me from unexpected angles, as if the walls were redirecting it deliberately. The pride drains out of his words and something colder moves in. September 9th, they tested the equipment last night. I was not informed. I arrived this morning and found dust disturbed in patterns across the floor. Concentric rings radiating from the center of the hall, as if something had vibrated through the entire structure. The final entry about the station is short, almost exhausted. September 22nd, I have requested a transfer. I am told my concerns are unfounded, that all installations meet safety standards. But standards for what? This is not a railway terminal. This is something else, and I no longer wish to be part of it. Then there's a night guard's testimony, recorded decades later for an oral history project. He worked in a palace station from 1896 to 1902. Late shift, midnight to dawn. His job was simple: patrol the empty halls, check locks, make sure nothing had been disturbed, but the halls were never truly empty. There were nights, maybe once a week, sometimes more, when the building would hum, not loud. You wouldn't notice it if trains were running or if people were talking. But at 3 in the morning, when everything was still, you'd hear it, or you'd feel it, really. A vibration coming up through the floor. It wasn't the trains. I knew the trains. This was different, steady, like the whole building was holding one long note. And during those nights, I'd get headaches, pressure behind my eyes. My chest would feel tight, like I couldn't get a full breath. One time my lantern flickered, just flickered on and off, even though the fuel was full and the wick was trimmed. I asked my supervisor about it. He said it was the weather, air pressure, told me to ignore it. But I noticed something. Those nights always came after the evening inspection trains. You know, the ones that ran after passenger service ended. Always the same schedule. And always, a few hours later, the humming would start. He pauses in the recording. I never felt safe during those nights. The building felt awake, like it was doing something, and I was just in the way. Then there's a student's letter written in 1898 to a professor of physics. She describes visiting a newly opened palace station, waiting for a connection, standing near a glass display case in the main gallery while her train was delayed. I heard a tone, very low, almost below hearing. I felt it as much as I heard it. I thought it might be machinery or distant trains. But then the glass in the display case began to tremble, not violently, just a faint vibration. I touched the glass and felt it humming beneath my fingers. I looked around. No one else seemed to notice. The tone continued for perhaps 3 minutes, then stopped. The glass went still. I mentioned it to the station attendant. He smiled politely and said, "Old buildings make noises. But, Professor, this was not random noise. This was a pure tone, sustained, controlled. What would cause glass to resonate so specifically in a railway station?" If the professor wrote back, the answer didn't survive. And that's the part that hits hardest. These weren't one-off ghost stories. Across multiple stations and multiple years, people describe the same set of things. Unexplained vibration, a held steady tone, physical sensations, headaches, pressure, tightness in the chest, the feeling that the air has changed. They describe it happening on specific nights, at specific hours, often after specific late trains. The architecture was precise, the equipment was hidden, the tests were timed, but the people inside the machine couldn't be hidden, and they felt what the stations were doing. The pattern wasn't trapped in Europe. When you push the research wider, the same architectural fingerprints show up farther away. across oceans in cities with no obvious reason to copy those European halls so closely. Same era, same design, grammar, same strange extras that never get explained. A palace station opens in Buenos Aires in 1897, Retiro Station. A massive iron and glass structure, a vaulted main hall, a dome that follows the same 3:2 proportions, hollow support columns. Basement chambers described in construction notes as auxiliary mechanical spaces. The architect trained in Paris. He worked on European railway projects in the 1880s before relocating to South America, and his Argentine station echoes what he saw abroad, not only in style, but in structure. Blueprints show the same hidden cavities, the same geometry that favors resonance, the same careful sound math inside spaces meant for ordinary passengers. A local newspaper from 1898 describes the opening ceremony. It praises the grandeur, the modern comforts, the symbol of a new age. Then it slips in one detail that doesn't belong in a normal celebration. During the inaugural speech, guests noted a peculiar acoustic quality in the main hall. The speaker's voice seemed to emanate from multiple points simultaneously, creating an unusual sense of presence. Engineers attributed this to the hall's exceptional design. Exceptional, yes, but accidental? Melbourne, 1901. Flinders Street Station, another grand terminus, another domed hall. Another cluster of features that rhyme with the European pattern. A postcard from 1903 shows the main waiting area. Sunlight spills through the glass roof. Passengers gather near ticket booths. And in the upper right corner, barely visible, slightly out of focus, there's something odd on the floor. Dust, but not random dust. Concentric circles spreading outward from the center of the hall toward the walls, like the room had been shaken in a clean, repeating pulse, strong enough to disturb what had settled, gentle enough to leave a pattern instead of a mess. The postcard caption reads, Flinders Street, Melbourne's gateway to progress. No mention of the circles, no explanation for why the dust looks organized. Then you start seeing the same kind of quiet evidence in other images. Postcards, tourist photos, small snapshots that were never meant to be studied like crime scene documents until now. A station in Kyoto, 1904. Dust patterns spiraling around the bases of columns. A station in Cape Town, 1906. Worn floor tiles forming faint rings, as if feet in vibration followed the same invisible track again and again. A station in Montreal, 1909. A photograph where the chandelier looks slightly blurred, motion blur in a long exposure, hinting the building was vibrating during the shot. Each image is subtle, easy to dismiss. Bad camera, cleaning day, old paper, but taken together, they point in one direction. These buildings experienced regular, patterned vibration, strong enough to leave traces, repeated enough to show up again and again. Then come the diaries. A German traveler in India, writing in 1902, visits Victoria Terminus in Bombay. He admires the scale, the ambition, the ornament. Then he adds a line that turns the page cold. In the evening, waiting for a delayed connection, I experienced the strangest sensation. A low tone, barely perceptible, seemed to fill the hall. I felt it more in my bones than in my ears. Other passengers appeared undisturbed, but I found it deeply unsettling. The tone persisted for 10 minutes, then ceased as abruptly as it began. A British engineer stationed in Shanghai in 1907 visits the city's new terminus. His journal entry is short, practical, and weirdly familiar. The hall's acoustics are remarkable. I clapped once and the echo returned with unusual clarity, almost as if the building were responding rather than merely reflecting. I am told the design incorporates European principles, though adapted for local conditions. A merchant traveling through São Paulo in 1908 writes home about Luz Station. The building hums, not always, only at certain hours. The locals seem accustomed to it, but I found it unnerving, like standing inside a giant bell just after it's been struck. Different continents, different climates, different languages, different railway companies with no single office linking them together. But the design logic travels anyway, carried by architects, engineers, and technical consultants trained in Europe, bringing the same geometry and the same habits of hiding the real function under polite labels. One researcher compiles a global map: 53 palace stations in Europe, 27 more across Asia, Africa, Australia, and the Americas. 80 stations total, built in roughly a 30-year window. Not all survive. Some were destroyed in wars. Others were gutted or flattened during modernization. But enough remain to show the same repeating shape, like a song you recognize even when it's played on different instruments. A network, global, held together by shared knowledge instead of a single ruler's order. Stations designed to resonate, built on the same principles. And sometimes, just sometimes, their schedules look too neat, too timed, as if the activation hours could have lined up across time zones. If these stations were experiments in wireless power or signal transfer, then they weren't isolated tricks in one city. They were nodes in something much larger. And for a brief window, 1890 to 1910, that system may have been alive. Then something changed. Whatever this system was, it didn't fade slowly. It stops like a switch being thrown. And when you trace the timeline, you see the same sequence repeating, city after city, station after station, inside a tight window of years. Between 1908 and 1914, something changes. Start with the renovations. A station in Vienna goes through modernization in 1909. The public description is boring on purpose. Routine work, better passenger flow, updated facilities. But the renovation records tell a different story. The basement chambers are filled with concrete, not repurposed, not converted, filled completely, sealed like a tomb. The hollow columns are reinforced with internal supports, killing the empty cavities that used to respond to vibration. The dome gets a suspended ceiling, a flat surface hung roughly 15 feet below the original curve, breaking the geometry that once shaped the sound. Metal ribs are removed from the roof for safety inspection, and never return. The work lasts 4 months. The cost is enormous, far beyond what routine maintenance would justify. And yet, the Railway Commission signs off with almost no discussion on paper. When the station reopens, the public sees the same face, same marble, same decoration, same grand first impression. But the building is different now. Acoustically, it's dead. The resonance is gone, then the pattern repeats. Budapest, 1910, major renovation, basement sealed, columns filled, the singing behavior disappears. Prague, 1911, a safety upgrade that includes removing unexplained metal fixtures and sealing underground rooms. Berlin, 1912, a small fire in a storage area becomes the excuse for sweeping structural changes, including the removal of resonant features nowhere near the flames. Each station gets a different official reason: maintenance, safety, modernization, fire damage, structural concerns. But the results match like copy and paste: remove the resonance, seal the chambers, break the acoustic precision, and in case after case, the work happens fast, quietly, with very little public detail. Then come the real disasters. A fire in a Warsaw station in 1911 destroys the East Wing. Reconstruction plans show a totally different interior: flat ceilings, solid walls, no acoustic extras. Flood damage in a Budapest basement in 1912 leads to a permanent sealing of the lower levels. The water damage is real, documented, serious. But the decision to seal instead of repair is strange. Railway companies don't usually abandon expensive underground infrastructure because of water. They pump it out. They rebuild. They restore service. Unless sealing the basement solves a different problem. A partial collapse in a Prague gallery in 1913. A section of ceiling gives way during routine work. No one is hurt. Damage is moderate. But instead of restoring the original design, the whole ceiling is replaced with a modern flat layout. The acoustic geometry, untouched by the collapse, gets removed anyway. One engineer's private notes question the choice. The collapse section could be restored to original specifications for less cost than total replacement. I do not understand the Commission's insistence on a new design. At the same time, the archives begin to change. Documents that should exist stop existing. Equipment inventories from the 1890s vanish from railway files. Maintenance logs end abruptly or have pages torn out. One archivist finds something especially telling. A station's full architectural plans are stored in a municipal archive, supposedly untouched since deposit in 1895. But under ultraviolet light, the paper shows traces of removed pages. The binding had been opened, sections extracted, then the whole set was rebound to hide the gaps. And the missing pages are always the same type: basement layouts, equipment specifications, notes about acoustic design. Someone wasn't burning the evidence. That would draw attention. They were doing something colder, quietly pulling out the pages that explain too much. By 1914, the pattern is hard to deny across dozens of stations. The resonant features are gone. The equipment is removed, the chambers are sealed, the paper trail is cleaned, and then World War I begins. The war becomes perfect cover. Scrap drives justify removing iron ribs and fixtures. Security concerns justify locking basements. Material shortages excuse tearing out non-essential elements. By 1918, many palace stations have been gutted of anything that made them behave like instruments. The halls remain beautiful, grand, impressive, but they're quiet now. Whatever these stations were built to do, they don't do it anymore. And the timeline forces one question. If this was just architecture, just style, plus some accidental acoustics, why remove it so systematically? Why fill chambers, solidify columns, strip fixtures, and clean records? You don't erase something that never mattered. You don't spend enormous sums killing a feature unless it was doing something important. Something worked inside these halls. Something happened, and someone decided it had to stop. Walk into a palace station today. The marble is still there. The arches are still there. The grand entrance still opens into a vaulted hall that makes you feel small. Like you've stepped into a room that remembers a different century. But something is missing. The first thing you notice is the ceiling. Where there should be a soaring dome, there's a drop ceiling. Flat panels, acoustic tiles, fluorescent lights. Modern, efficient, practical. The original dome is still up there, above the fake ceiling, hidden in darkness. But you can't see it. And more importantly, you can't experience it. You can't hear what it used to do. You can't feel how the room used to behave. A station in Vienna installed this ceiling in 1967. The renovation was described as modernization for improved climate control. The dropped ceiling created space for ventilation ducts, wiring, and insulation. It also cut the hall's acoustic volume by 60%. And whatever resonance survived the earlier gutting, whatever small memory the room still had, was wiped out. Now, look at the walls. Advertising panels cover the marble, bright, loud, impossible to ignore. Every flat surface becomes a billboard. Every clean sightline gets chopped up by branding, and the ads do more than sell things. They break the room's geometry. Hard surfaces at awkward angles, reflective plastic and glass, uneven shapes that scatter sound in messy, unpredictable ways. One acoustic engineer measured the effect. He compared recordings of the same hall from 1920, after the early renovations, but before the modern advertising takeover, and from 2015. The 1920 recording still shows a trace of resonance, faint but present. Certain tones still bloom a little. The room still answers sound, even after its core features were damaged. The 2015 recording is flat, diffuse, dead. No bloom, no lift, just scattered reflections that cancel each other out. His conclusion: the advertising isn't just visual clutter, it's acoustic clutter. Intentional or not, it destroys any remaining resonant behavior. The columns are hidden now too, wrapped in modern cladding, information kiosks built around their bases, panels and covers that turn old supports into blank shapes. The columns that once stood exposed, part of both the beauty and the sound, are now buried behind drywall, plastic, and metal skins. You can't tap them. You can't test them. You can't even see where the stone ends and the modern cover begins. A maintenance worker in Prague described finding a sealed column during renovation work. The cladding was removed temporarily for inspection. Inside, the column was hollow, but filled halfway with debris, broken concrete, bits of metal, rubble. Someone just dumped it in there and sealed it back up, he said, like they wanted to make sure the space couldn't be used again. And the basements are worse. Most of them are simply off limits now. Locked doors, boarded passages, staircases that end at brick walls. The official reasons are always the same: safety concerns, structural instability, abandonment. But when basements do get opened during utility work, emergency access, or rare restoration, they often reveal something unsettling: empty chambers, smooth, finished walls, vaulted ceilings, spaces that look designed, not accidental, built for people to enter, built for something to happen down there. And then, abruptly, they're blocked again. Concrete poured into doorways, rubble packed into passages, entire rooms made unreachable not by collapse, not by time, but by deliberate filling. One worker described finding a chamber with multiple corridors branching away, each corridor sealed with poured concrete stamped with different years: 1911, 1923, 1958, as if every generation stumbled onto the same space and decided it had to be closed again. In most stations, the transformation is complete. The shell remains. The beauty, or enough of it, survives. Tourists photograph arches. Commuters rush through without looking up. But the function, whatever it once was, is gone. The resonant chambers are filled. The hollow columns are blocked. The acoustic precision is shattered by flat ceilings and wall panels. Progress kept the palace and removed the instrument. Yet not everywhere. A handful of stations escaped full modernization. Remote locations, lower traffic. Not enough money to update everything. In those places, fragments remain. A stretch of original ceiling untouched. A basement level still reachable. Columns still exposed, still hollow, still honest. And in those fragments, you can still test the old behavior. One researcher visited a partially preserved station in Eastern Europe. He stood in the center of the original hall, no drop ceiling, no wall adds, minimal modern alteration. He clapped once, the sound came back. Not as a normal echo, as a held tone. Faint but unmistakable. The room still responded. The palace was still trying to sing. The erasure was thorough, but it wasn't perfect. Engineers can pour concrete. Planners can hang fake ceilings. Committees can rename things in paperwork. But they can't undo the basic architecture without tearing the whole building down. The bones stay. And if you know what to look for, the evidence is still there, hidden in plain sight. Start with the arches. Walk through any preserved palace station and count them. Watch their spacing. Measure the distance from one arch to the next along the main gallery. In a station built in 1892, the arches sit exactly 7.2 meters apart. Every single one, not about. Exact. Over a gallery stretching 180 meters. Why that distance? An acoustic researcher calculated the wavelength of the hall's dominant resonant tone, the low note the space naturally wants to amplify. The wavelength matches the arch spacing. Precisely. That means the arches aren't just decoration. They act like acoustic nodes, fixed points where standing waves form and repeat. The architecture is frozen math, and it's still there. People walk under it every day without realizing what it's doing. Now look up where the walls meet the ceiling. In stations that escaped full renovation, you can still find metal anchors, small, often painted over, set into stone at regular intervals around the rim of the main hall. Most modern workers assume they're old mounting points for lamps, banners, or holiday decorations. But the spacing doesn't match lighting needs. The anchors sit it acoustically. Important points. Spots where sound pressure would peak inside a resonant chamber. Places that matter if the room is meant to lock into a tone. One preservation team discovered something worse. The anchors don't stop at the surface. They run deep into the wall, tied into iron rods threaded through the masonry. Not random rods, not simple reinforcement. A network, metal lines running through the building's stone body like nerves. Still there. Still able to carry vibration. A structural engineer examined the system and said, "This isn't reinforcement. The rods don't follow normal load needs. They follow acoustic patterns, linking resonance points and creating a conductive path for vibration." Then there are the basements. Even when sealed, they leave fingerprints. Ground-penetrating radar can map what's under the floor without opening a single door. And again, scans reveal chambers beneath modern stations. Large hollow spaces that shouldn't exist under buildings that are supposedly filled and solid. One researcher mapped a Prague station with radar. The scan showed a chamber directly beneath the main hall, about 30 meters wide and roughly 12 meters deep, with a vaulted ceiling that mirrors the dome above. Official plans list that zone as filled foundation, but the radar showed a void, empty air. When asked, the railway authority insisted the chamber was inaccessible and unsafe. They refused any inspection. So the researcher returned at night with acoustic sensors. He placed them on the main hall floor and played low-frequency tones. The sensors picked up an answer from below. The sealed chamber was responding. Whatever is down there is still hollow, still shaped, still able to resonate. Then you hear the stories nobody puts in reports. A maintenance worker in a Berlin station describes routine repairs in a service corridor. While tracing electrical conduits, he noticed a door, unlabeled, not marked on any plan he could find, sealed with a padlock that looked decades old. He asked his supervisor about it. "It's been there forever," the supervisor said. "Nobody knows what's inside. We're told not to open it." Similar stories surface from other stations. Sealed doors in basements, locked passages behind false walls, stairs that lead down to levels that officially do not exist. One worker opened a door like this in a Warsaw station. Inside was a small circular chamber with smooth stone walls, empty except for mounting brackets set into the walls, the same kind found in the main halls above. No storage marks, no pipes, no utilities, no practical reason to be there. Just a clean, finished room, hidden like a secret. When he reported it, the door was welded shut within 2 days. Even the modern changes betray intention. In Vienna's main station, a renovation in the 1970s boxed off part of the original basement. Concrete walls were poured to create equipment rooms, but the concrete is far thicker than any normal equipment partition needs, in places nearly 3 feet thick, reinforced with steel mesh. A consultant looked at the plans and said, "This isn't load-bearing. It's not even sensible design for utility rooms. These walls are built to contain something, to keep vibration from traveling. The rooms behind them are labeled disused storage, yet the doors have modern locks, and security cameras were added in 2003. Storage rooms don't get that kind of treatment. The palace stations were gutted, reshaped, and covered up, but the core geometry is still there. You can't remove it without demolishing the entire building, and beneath the fake ceilings, behind the new walls, under the ads and the crowds, the resonators still exist, waiting." So, what were these stations actually for? You've seen the clues, the acoustic precision, the hidden chambers, the missing pages, the careful cleanup in photos and files, the people who felt something happening inside these halls. But clues are not the same as a full explanation. So, let's do this the honest way. 3 possible readings of the same facts. No wild claims, no secret empire speech. Just 3 ways the evidence could fit. Option 1. Advanced acoustic engineering for practical purposes. The simplest explanation is also the most ordinary. These stations were designed with unusually smart acoustics to solve real station problems. In the late 1800s, there were no loudspeakers, no handheld radios, no clean modern paging systems. If you needed to reach 2,000 people in a giant hall, you had one tool, the room itself. Shape the space right, and a single voice can travel. Cathedrals proved that long before electricity. Domes can focus sound. Arches can guide it. Surfaces can push speech into clear lanes instead of letting it dissolve into noise. The hollow columns could have helped reduce low, heavy train rumble, making higher tones, like speech, stand out more. The basement chambers could be part of ventilation that also controlled echo and feedback. The hidden equipment could be early work on pneumatic systems, compressed air used for signals and timing, mixed with acoustic pipes and pressure pulses. This explains the math, the ratios, the careful tuning. It's not magic. It's just engineers doing elite work with stone, iron, and geometry. And the erasure? That can be explained too. Once electronic speakers and modern systems took over, the old acoustic tricks became less important. Renovations focused on climate control, wiring, signage, crowd flow, not on preserving vintage resonance. In this reading, the story is not a cover-up, it's obsolescence. Option 2. Experimental infrastructure for energy and communication. The second possibility is bolder, but still grounded. These stations were test beds, public buildings used as real-world labs. The 1880s and 1890s were an explosion of new ideas: alternating current, wireless telegraphy, resonance theories. People were trying everything because nobody knew what would win. Palace stations offered perfect conditions: huge enclosed spaces, controllable schedules, basements and service corridors nobody questioned, a steady stream of workers who followed instructions, and built-in sources of vibration and energy: trains, generators, mechanical systems. In this reading, the resonant design wasn't just about sound for announcements. It was also about transmission: signals, vibration, or energy carried through the building and possibly into the ground. The hidden chambers held experimental gear. The special crews installed it at night. The time train intervals acted like rhythmic inputs, feeding the system in repeatable pulses. Some tests may have worked, some may have failed, but by 1910, radio and modern electrical grids were moving fast, and a station-based resonance system may have become the wrong path. So the equipment was removed, the pages were pulled. The project ended quietly, not because it was forbidden, because better tools arrived. Option 3, dual-purpose infrastructure, 2 functions in one building. The third possibility is the most realistic blend. Both things were true. These buildings were real train stations. They moved millions of people. That part is not fake. But they may also have carried a second function. The same geometry that helps speech travel can also shape vibration in other ways. The same chambers that move air can also house equipment. The same precision that makes a hall feel alive can also make it stable for testing. Dual-purpose design is normal in the real world. A modern building can have a lobby upstairs and a data center in the basement. The lobby is still a lobby. The data center is still a data center. Both are real. In this reading, the station served the public honestly and served research quietly. That would also explain the secrecy. If railway commissions or engineers were testing new transmission systems, they wouldn't advertise it to passengers. It could be sensitive, expensive, embarrassing if it failed, or simply private. And when the second function ended, success or failure, the easiest move is simple: remove the gear, seal the rooms, clean the files, and keep the station running. So, which one is correct? The honest answer is, we don't know. The documents are incomplete. The witnesses are gone. The hardware was removed. The photos were edited. Too many key pages are missing, right where the story should become clear. But here's what we can say with confidence from the pattern itself. The stations show extraordinary geometric and acoustic precision. That precision served some purpose. Those features were later removed deliberately. And the records were cleaned in a systematic way. Something real happened in these halls, whether it was brilliant acoustic engineering, quiet technical experiments, or a design that did both at once. The architecture still remembers what the archives tried to forget. Whatever these stations were, they didn't just vanish from technical files. They faded out of human memory: the craftsmen who built them, the engineers who understood them, the shared knowledge itself. And that kind of erasure always has a price. Start with the builders. Palace stations didn't go up like ordinary terminals. They demanded extreme skill. Stonemasons who could shape curves that weren't just pretty, but precise. Metalworkers who could forge iron ribs and fixtures that had to sit in exact places. Craftsmen who understood geometry not only by sight, but by sound, whether they called it acoustics or not. Employment records from the 1880s and 1890s list hundreds of specialized workers on single projects. Master craftsmen, technical specialists, roles that read like a different world, job titles you almost never see today. Then, after 1910, the language shifts. In the 1920s and 1930s, station projects still hire plenty of labor, sometimes even larger crews, but the specialty disappears. General construction workers, standard engineers, basic foremen, no acoustic specialists, no resonance roles, no consultants for tune geometry. Where did the knowledge go? Some craftsmen retired, some died. That's normal, but skills that valuable don't usually vanish overnight. They get passed down. Apprentices learn. Workshops keep methods alive, unless the work itself is stopped. Unless there is no reason to teach the skill, because nobody is building that kind of architecture anymore. The technical drawings tell the same story. Early palace station plans feel like a different species of blueprint. Dense, careful, proud. Measurements that repeat like a code. Notes that connect shape to behavior. Evidence that someone cared about more than will it stand. Later plans simplify. The why disappears. The annotations turn bland. Decorative dome, support column, basement storage. The buildings can still look similar, but the understanding is gone. It's like finding sheet music with all the notes, but none of the instructions for how to play it. The page looks complete, but the performance dies. A preservation architect once reviewed renovation plans for a station from 1928. The new design mimicked palace style, domes, arches, grand halls, but the proportions were wrong. Beautiful, yes, but acoustically meaningless. They copied the appearance, she said, but not the principles. It's like drawing a violin without knowing it's an instrument. The shape is there, but it won't sing. Then came the scrap drives, World War I, World War II. Metal became life and death. Governments begged citizens to donate anything that could be melted down, and palace stations were full of metal, iron ribs, bronze fixtures, strange brackets, panels and frames that were easy to label as ornament if you didn't want to explain them. So, they were stripped. One station's records list the removal of 498 kilograms of ornamental iron fixtures in 1915. Another notes decorative bronze elements, approximately 1,200 kilograms, removed in 1942. The paperwork calls it patriotic duty, necessary sacrifice. But if those fixtures were functional, if they were part of a tuned system, then removing them doesn't just change the look, it breaks the behavior. After the wars, restoration teams tried to replace what was gone. New fixtures were cast. New pieces were mounted in roughly the same spots. But roughly doesn't work in a system that depends on exact spacing. In resonance, a few centimeters can be the difference between a clean response and nothing at all. So the stations were patched, not restored. They could resemble the original, but they no longer functioned the same way. The human cost wasn't only physical. A 1951 interview with an elderly engineer, one of the last men who had worked on original palace stations, shows the emotional damage too. I watched them tear out the ribs, fill the chambers, drop the ceilings. They told us it was progress, modernization, making things better. But we knew what we were destroying. Not all of us knew the full purpose. That knowledge was restricted, but we understood it was precise, intentional, beautiful in ways beyond appearance. And we were told to erase it, make it ordinary, turn instruments into warehouses. I stopped working on station projects after that. Couldn't bear to watch. Then the books began to vanish. Technical manuals on acoustic architecture from the 1880s and 1890s became hard to find. University collections that once held shelves of niche engineering texts now have one volume, or none. Some losses make sense: wars, fires, neglect. But a librarian in Vienna recorded something else. In 1923, her institution received an order to review and remove outdated technical materials to make space for modern references. The removed books weren't simply thrown away. They were collected, logged, and taken by representatives from the railway ministry. It wasn't about space, she wrote in her diary. It was about making sure certain information stopped circulating. By 1950, the knowledge was effectively dead. The craftsmen were gone. The books were removed, the buildings were changed until their original behavior became impossible to test. A new generation of engineers grew up without even knowing that resonant architecture had ever been treated as a serious discipline. And that's the real cost, not only the loss of buildings, but the loss of what human hands and human minds once knew how to do. Go back to where we started, a grand station at night, marble floors, iron ribs, glass roof. The crowd has gone. The announcements have stopped. You stand in the center of the hall, and you listen. This is not a thought experiment. This is something you can test. A researcher stands in a partially preserved station in Eastern Europe. It's 2 o'clock in the morning. The last train left about an hour ago. Security granted access for acoustic testing, reluctantly, with rules, with observers watching. The station still has its original dome. No drop ceiling, minimal modern alteration. One of the few survivors. The researcher places sensors at calculated points around the hall. He positions a low-frequency speaker at the center. The equipment is precise and professional, built for measurement, not drama. He plays a tone, 112 Hz, the same frequency mentioned in that Restorers report from 1889. For a moment, nothing happens. Then, the hall answers. The tone doesn't just bounce back as a normal echo. It gathers, the walls catch it, the columns feed it upward, the dome bends it back toward the center. The sound grows, holds, and fills the space like a steady pressure. The sensors catch something else. A second frequency appears, then a third. Harmonics. New tones the speaker never played. The building is adding its own notes. The hall is singing. The researcher shifts the frequency upward, slowly, carefully. Not chasing a thrill, checking a range. At 168 Hz, the metal ribs in the ceiling begin to hum loud enough to hear. At 224 Hz, the floor starts to tremble under your shoes. At 336 Hz, the glass in the windows shivers. Each response is clean, repeatable, predictable, not random, not a lucky accident. This behaves like a tuned instrument. After more than 110 years, it still works. The security observer looks uneasy. He has worked in this station for 15 years. He has never heard the hall do this. Should it be this loud? He asks. The researcher checks the readings again. The speaker is outputting a modest signal, nothing extreme, but the hall is multiplying it by a factor of 20, sometimes 30, depending on the frequency. It's designed to do this, the researcher says. We're just hitting the right notes. The observer walks to the edge of the hall. He places his palm against a column. He feels it vibrating, alive, under stone. What was this for? He asks. The researcher doesn't answer right away. He's still logging data, still mapping the response points, still watching the pattern draw itself across the room. Finally, he says quietly, I don't know, but it was for something. The test runs for 90 minutes, a sweep across the range, measurements repeated, responses confirmed. The architecture is not just pretty, it is a working system, built to react. When they stop, the hall returns to silence. But it's a different kind of silence now. Not empty, not dead. It feels patient, like a thing that has been waiting for the correct touch. The researcher packs the equipment. The observer locks the hall behind them. As they walk away, the observer asks one more question. If this one still works, do the others? The researcher thinks about sealed basements, filled columns, dropped ceilings. The quiet pattern repeated across dozens of cities. Some of them might, he says, under everything we've done to them. The geometry is still there. History is not a straight line. It's layers, cities built on cities, new walls over old systems. We pave, rebuild, modernize, again and again. The past doesn't always disappear. Sometimes it gets buried on purpose. These palace stations were built for a purpose we still don't fully understand. They worked briefly, quietly, and then the story was cleaned up. But the bones stayed, the curves stayed, the proportions stayed. You can cover an instrument, you can mute it, you can hide it behind panels and ads, but you can't unbuild the tuning without demolishing the whole body. And sometimes, in the early morning, when the crowds are gone and the trains are silent, the halls still remember. Now, picture rush hour. Thousands of people, announcements, footsteps, trains arriving and leaving. You look up at a dome hidden behind a modern ceiling. You look down at a floor covering chambers you'll never see. And you wonder, what else did we build that we no longer understand? What other instruments are still inside our cities, still tuned, still waiting for someone to remember how to play them?